Alrighty, tidy folks. Today I'm working on an '02 Volkswagen GTI Turbo. Somebody had plumbed the wastegate control valve wrong, and I saw some flickering in the lights. So why don't you come along with me for the ride while we check those things out and see if we can't get them fixed. Hope you enjoy. While checking some of the tubing, sometimes no matter how gentle you are, things break. And I actually did break the wastegate control solenoid last night while just checking things around. I was moving stuff, twisting stuff, seeing if anything was loose, and I broke the boost control solenoid. So it broke right there at the body. I don't know where. I think it's in the car. Let me grab it. While checking it out, after observing the boost surge, my first suspicion was the wastegate control valve. And while moving some hoses, I ended up breaking the one that was on the car. It broke right here between the body and this splitter valve here. So I went and I got me a new one. So I went and got me one from the junkyard, and it just so happened that the customer lost this clip at some point fairly recently, apparently. So while I was there, I also grabbed a little bit of a pigtail. The wastegate control solenoid, or what does Volkswagen call it? The wastegate frequency control valve, goes right here in the intake, with one port going to pressurized intake, one side going to the wastegate, and one side going to fresh air. I guess you don't want this valve itself always being under pressure. So when the valve is closed, this is a pass-through from the pressurized intake to the filtered intake, pre-turbine, and then when you open, you get pressurized air from the pressurized inlet side to the wastegate side to open the wastegate, to bypass the turbo, to reduce intake pressure. So the first thing I'm going to do is we're going to put him on there, but then I want to check and see if the issue is with the old valve. The computer controlling the valve is sending the signal wrong, or if the issue is actually in the turbo. There's a number of things that could cause a control issue. Mass airflow issues. There's a pressure transducer somewhere for the inlet that tells the ECU how much boost pressure there is. That could be bad. One of them could be the blow-off valve is opening prematurely. It's not electronic, it's manual. It's controlled via vacuum and boost pressure, so pressure differential across the diaphragm. It could be faulty, opening prematurely and bypassing the boost into the non-boosted side of the inlet there, pre-turbine. The wastegate control valve could have been bad, and when the ECU commands a PWM into the valve, instead of opening some amount, it was simply opening full, opening the wastegate completely, dropping off, bypassing the turbo, dropping the boost off to nothing, at which point the ECU said, oh, I'm commanding more, I need more, so it would close the wastegate by turning this valve off, at which point the boost pressure would rise again, and you get into this kind of infinite feedback loop where, because the valve is opening too far, the PID system in the ECU can't account for that, or it doesn't have PID control, and you just run into this constant cycle of boost, no boost, boost, no boost. Okay, so the first thing we're going to do is I'm going to install this valve, but I'm going to disable it. I'm going to plug the electrical connector in, because otherwise the ECU will complain about it and may not control the boost correctly, or may not fuel correctly, or may not advance the ignition correctly, or it might go into some, not limp mode necessarily, but it might go into some default safer mode, which would not allow me to perform tests. So we need to put the valve on, plug it in, and then I'm going to disable wastegate control by pinching close the wastegate line and seeing if the boost surge is mechanical, i.e. the turbo, or if it's electrical. If it'll go up to, say, 10, 11, 12, 14 PSI and hold steady during a long pull, the thing would surge every 2 seconds, 3 seconds. So if it'll maintain boost for 10 or 15 seconds, the turbo is likely fine. Now this car's got 300,000 miles on it. It's 280 or thereabouts. The turbo has never been rebuilt. Turbos generally last 50 to 100,000 miles depending on the turbo, depending on the design, depending on where it's placed in the engine bay, etc., etc., all kinds of different factors. This thing should have been rebuilt twice by now. So the fact that it's lasted this long without problem is quite impressive, actually. So there's the body of the one I broke, and there's the piece that's supposed to go into it right there. You can see that plastic is really, really thin. Not really the best design. This is an OEM part, so I would expect it to have been stronger than this. The way this thing is designed and built, there's your valve system right there. There's a spring that goes on there that's over on the bench there, but just does that, and then the solenoid pulls that mechanism, pintle actually, pulls the pintle away from that piece right there and allows air to pass from one system to another. So the customer took it to a mechanic who installed this guy on there. This is a manual boost controller, which all it is it's a variable bypass valve is what this is. The more you open this, the more air is allowed to bypass there. It's effectively a proportioning valve, because eventually, under a steady state, the one side will stabilize and equalize at the same pressure. It merely limits the rate at which the pressure can change. That's all this does. So under transients it works fine. Under a steady state, it doesn't. So if you're climbing up a long hill with this is your boost control mechanism to your wastegate, what you would end up getting is your boost would climb to some point, and at the point at which your throttle is and you become steady state, and then as the air bled through the valve, your boost would drop, and then you'd have to put more throttle into it, and then the boost would rise, and then it would stabilize and your boost would drop. And don't use these. There's no point for them on a system like that. So we've removed the incredibly poor idea, the manual control valve, which this thing's got an electronic control system. Why do you need to install a manual control valve? Come on. Then somebody put these far too large for the hoses clamps on here. Always get the right hose clamp for the job. I am going to reuse them for right now because we are just testing. It's not a huge deal. But we want to place this guy in here. We actually want to turn that hose clamp around. You also need to pay attention to which way your hose clamps are facing when you put things on. So many people don't, and then you can't get to the clamp, or you can't interact with the clamp once everything's together, because they only look at how the clamp is going to be accessed when everything's taken apart. We do not do that. When we modify, when we design, when we build, when we work on anything, we make sure, we ensure there you go again. Those clamps the wrong way. We ensure the system can be worked on in the future without having to remove everything. And with worm clamps, let's get a zoom in here. With worm clamps, you know it's too big when you have all this left over when you're done tightening the clamp. Look at that. That is ridiculous. These are definitely the wrong clamp for the job. Same here. Wrong clamp for the job. Always, always, always make sure you are using the right tool, the right part for the job, if you can manage it. There's no cause. You can order the right clamps. They're $1. It's not that big a deal, especially for a shop. Shops get breaks and things like that. This is a different clip, a slightly different connector. Strange. Well, that's not going to work then. Okay. Now, my other larger, easier to read vacuum / boost gauge only goes up to 10 psi. So I grabbed one of these guys, goes up to 30. It doesn't need to be accurate. I only need to be able to determine if my boost is coming on and remaining stable or not. Somebody also put a worm clamp on the fuel pressure regulator's vacuum line, which makes no sense to me. It's a vacuum line. Yes, it gets boost pressure, but it should be tight enough on there, it shouldn't matter. Or you leave the damn squeezy clamp on there. Easy. Now I've got the clip back on the wastegate control valve. I actually had to rob it from the intake temperature sensor, which you can see I've sort of zip tied into place for a temporary solution. We will have to get a new clip to replace the missing one eventually, but for testing purposes for today, the customers got another vehicle they can drive, so we can have this for a couple of days if we need it. So we'll find a clip at a junkyard or online somewhere. The one I got from the junkyard was actually a different connector retainment mechanism. It's the same connector design, but it's a different mechanism that retains it. Where this style, you push the clip to release it. This one, you squeeze the metal bar there, and it springs off of the object that it is retained to. This style is the much better design. It's more reliable, it's easier to remove, it's a much better design. I'm not sure which way they went, if they switched from this to that or from that to this, but this is definitely the better solution. Now that we've got that on there, now that we've got that stuff back together and we've got the wastegate control blocked, it will not, oh, it is non-controllable. We're going to go on a test drive and we're going to see what the boost does without wastegate control. I'm hoping that without wastegate control, I'm hoping the wastegate is not pressure closed, but instead pressure open. Looking at the wastegate control valve though, I suspect it's pressure open, which might cause a problem. But we've bypassed the control mechanism. We're going to take it for a test drive. We're going to see what it does. And I'm going to take you guys along with me. I'll show you the stuff I got in the cabin. We're going to have to clear the code first because we drove around the other night, last night, with the solenoid disconnected. So there's a check engine light for that. That might affect something, the way the ECU controls stuff. I'm not sure. But we'll take it for a test drive and find out. See you there. So you can see there's a check engine light on. There's also an airbag light on. And there are other codes that exist. We'll be addressing those here in the future. Today is just the boost surge issue. And while I was driving it last night, I noticed the lights were flickering a little bit. So we're going to check out the electrical system after we do the boost check. I'd like to check it hot as I can possibly get it, just so that we know kind of the extreme case. Checking it cold, a lot of times you can get false positives checking it cold. There are some advantages to checking it cold, but for right now, it only seemed to do it after it was hot. So we're going to check it while it's hot after we do some boost checks. I don't think I'll be able to film while I'm moving, but I can hook up the scanner. So I can hook up my MaxiDOS here. Nobody connectors down here. It does sit at a bit of a angle to the kick panel there. Gonna get him secured in there. Get this guy started up. And this is a bit of an older machine, so it does take a minute or two to boot. Let's get that glare out of there for you guys. And this guy has a old school resistive touchscreen, which means there's two panels. As soon as it gives us the thing, we'll hit V-dub. It'll start trying to communicate. And what I'm going to do actually, real quick, because it'll re-establish the communication if I go into, so what I need is systems, control unit, because we know the specific one we want. Common, it's almost always in there. Engine. You can see the little car light down there blinking. It's trying to contact the computer. It finally made the determination that it was not connected and had to reconnect. So we're going to read the codes. Always read the codes first, even if you know what they are. Coolant tip sensor, we replaced it last night because it was showing us 260 degrees Fahrenheit when the engine was cold. So we replaced that. It seems to be working now. Catalyst system efficiency below threshold. That's generally an O2 sensor, but catalytic converters, they do have a lifespan, so it's possible the catalytic converter has failed. They're not cheap, but you can get weld-in ones that this one is fairly easy to get to. It's pretty simple to cut the old one out, weld the new one in, easy peasy. And then we see here, this is the one we really cared about. Boost pressure regulation valve. And you guys are, why will you not focus correctly? Thank you. Okay. This is the one we really care about, the boost pressure regulation valve. That guy we had disconnected because we broke it, and there was no point in leaving it just dangling from the harness without the retainer mechanism last night, so we just removed it completely and bypassed it. All right, so we know what all those codes are, we know why they're there. We will now erase the codes, which will also erase the freeze frame data. Okay, erase sent. We're going to try to read codes. System pass, no codes present. All right, folks, we're back. And on the test drive, we got on our gauge there, we went up to about 12 PSI. The problem with these cheapy gauges like this is they don't really have any kind of damping mechanism for the needle. So it went up to about 12. When I say that, I mean it was jumping around like, I don't know, something that Texans say a lot. But it was stable. What it was doing before is you could feel a definitive surge where you'd go on boost and then off boost while just holding the accelerator in a constant position. It is no longer doing that. So either the valve that was broken was bad, or it was hooked up wrong when the last guy that was in here took it apart and put it back on. I'm not sure which, doesn't really matter, seems to be fixed now. The next thing we're going to do is we're going to check the electrical system. Now the first thing I'm going to do, I'm going to check the state of the battery. The engine was just running, so we are going to remove the surface charge, which is real simple with our load tester here. Okay. We can see we've got 12 point, you can't see. Now we can see here, we've got about 12.4, 12.5 volts. That's fine. I'm going to apply a small load for just a few seconds to remove the surface charge. Now this battery says November of 2015 was its manufacture date. So now what we're going to do is we're going to see if we can't remove this cover, and we have a cold cranking amp of 650. Now, again, when we crank this guy up, we should get up to 650, which is just above the 600 mark there, before it drops down into the red on this gauge. So, that's what we're gonna do. No. So the battery is weak, which could explain the light flickering that I saw last night when I was driving it. What we're going to do now is I'm going to put the digital multimeter and the voltometer on here simultaneously. Because they both tell us slightly different information. Right? So, first things first, let's get the digital multimeter out here. Turn him on. Put him on voltage, DC. We'll set him here. Pull our little screen up. Alright, so On our 25 volt scale here, see 250, that's 10, that's 150, so we're at about 12 and a half. So everything agrees. We have multiple test units that seem to all agree. I'll watch the digital and the playback there. I still smell coolant leaking. I'm gonna have to wash this thing off. Alright, so now we're at idle. We're charging it 13.9, which feels a bit low to me, but it's acceptable. 13.6 is generally the limitation. 13.9 is acceptable. Now we will turn on some load. And I did recommend the customer did purchase a new battery and recheck the alternator after having replaced the battery, because the battery being weak can cause the alternator to appear to be weak or failing because the alternator can't keep the battery charged. We haven't had a chance to check it out yet. I'm not sure if the customer has replaced the battery or not. I will have to ask him next time I talk to him. And if he has, we'll check the alternator then. I'll record that and I'll show that to you guys. And I actually did fix the voltometer. I was having a problem with it trying to look at AC. And I did fix that, so the next time we're up there and we're looking at that, I can show you what that looks like properly. So keep an eye out for that video too. And that's all we've got for this video. If you liked it, don't forget to like it, subscribe it, crank it, and rip it, and we'll see you in the next one.